Good morning, everyone. Thank you so much for making the time. Today's our fifth session, actually. This is amazing. And we're going to be talking about something like I was just saying before the call, it's one of those things you don't think about, and then it can easily become the only thing you think about because actually, you could have a runaway bill that really threatens the existence of your organization. I mean, there's just no way around it. And I unfortunately have to have conversations with folks about that. You check something in the GitHub, or someone left a job running over the weekend. You come back and there's a gigantic bill. And some of the stuff in here, I would say, are must-haves, meaning that you absolutely have to do it. Some of the stuff in here, you kind of walk crawl. And at the end, I'll actually talk about walk, crawl, run, and what some of the stuff you can do to kind of get there. And I mean, unfortunately, the folks who tend to have this most understood tend to be larger organizations, as you might imagine, like Fortune 500 companies. They tend to have this well structured. But I've also seen folks, especially in the age of AI, leverage a lot of AI to really get on top of this as well. In fact, I'm frequently surprised at folks who give us insight into how they've been able to manage costs that goes beyond anything I even thought of. So at the end of the day, what we're really talking about is FinOps, right? Or financial operations, which, and particularly cloud FinOps, which is actually becoming pretty well understood, and it's becoming pretty formalized, actually. In fact, I suspect we'll soon have degrees in cloud FinOps or something similar to that, infrastructure FinOps, where basically you're able to understand what it takes to minimize the impact and get the most value for an organization for what they spend on IT resources. And at the end of the day, this is really the end game. And this is the vision of where you want to be as an organization. You want to have all your costs taggable, every resource mapped to a team, product, and environment. You want to have zero waste. Any idle resources immediately disappears and no longer costs you anything. And you want to have a really good baseline coverage for reservations. We call them CUDs here. Some of the vendors call them different things. And then you also want to have 100% forecast accuracy. You want to be able to tell what your bill is going to be at any given time. And I know in the age of everyone just turns something on, a lot of folks are thinking that's no longer a thing. But unless you've got enough cash to give you a runway for insane amounts of spend, you really do want to have some idea of how much you're going to spend, say, 30 days, 60 days from now. In
Hey,
terms
Len,
of, yes?
we actually have a intern here with us who is doing a degree tangential to this. It's already happening.
Oh, yeah. See, it's already happening. It does not surprise me. Yeah, because it's becoming very formalized. I definitely see that. So in terms of responsibility and in terms of, I guess, who's responsible for the different parts of the FinOps, IT, business, and finance have to collaborate. And that's not surprising. The big thing is that the engineering, of course, owns the SREs, owns the architecture, the automation, capacity planning, implementation of the guardrails. The engineering and finance also have to own the reporting, the portfolio management, chargeback, showback models. Finance and business have to own the unit economics, which is cost per inference, ROI. And then the idea is that this is how you establish a cost-aware architecture, and you can end up with blameless root cause analysis for budget overruns. Because at the end of the day, that's where you're trying to get to, right? Which is, one, you don't have budget overruns, but if you did, you'd be able to explain away exactly how it happened, and there'd be no gaps in terms of, hey, I thought I was supposed to do this and I didn't do it, and something like that. At the end of the day, because I'm focusing mostly on AI for this cost optimization, there's going to be a lot that's generic to cost optimization for this, but a lot of this is going to be focused on AI. We kind of have to separate out the two different, I guess you could say, dimensions that you could have AI costing on, depending on whether or not you're using API-based AI like generative AI, or using like an AI platform like we have stuff other than Gen AI actually, or you're doing your own custom model and inference on infrastructure. So in the billing unit for the API base would be billing tokens, which is inputs and outputs. I always have to emphasize to people that you're paying for inputs and outputs A lot of folks get caught up with the fact that, oh, this thing is X amount of tokens. You also have to realize that the output's going to be X amount of tokens, and you're paying for that as well. So be aware that that's the cost dimensions. When it comes to hardware, you're looking at node hour, which is the price of accelerators and the compute that's running them. For the SRE, their focus is on payload and data efficiency when it comes to generative AI, which is how can you basically get the most value for the tokens that you're submitting and also getting out. For infra, the SREs mostly focus on bin packing and hardware utilization. Because if you spin up a node, you want to make sure you use as much of that node as possible. And you don't want to have anything extra. You don't want to have an extra node or extra group of nodes in there. You want to be able to use as few nodes as possible. And the big risk for AI-based or API-based is that you can end up with infinite loops or bloated system prompts. And the infinite loops, especially in the early days of agents, where agents were making like looping decisions or branching decisions, that was a very typical thing that could happen. Basically, the LLM wasn't able to determine where to go next, so it just kept going over and over and over again. Bloated system prompts, this is something that once you start putting skin in the game using Gen AI, you begin to realize that you want to minimize your prompts as much as possible. You don't want any excess stuff in there. And there's services that can help with that, like memory and context. For hardware, you don't want idle endpoints. You don't want to spin up an expensive A100 and then have it 0% utilization. That is an absolute waste. And then you don't want to have more memory than you need. Like you don't want to, if your model can fit in 32 gigs, you don't want to have 64 gigs sitting around. That's a waste. Some of the optimizations you can do for Gen AI is leveraging RAG. Remember I was saying that you can do things to really reduce the size of prompts. Basically, you can leverage RAG to kind of guide how the inference works. You can do prompt caching. This is a capability that a lot of the models have, where instead of having to resubmit the same prompts, the long prompts, you can just use smaller prompts. And then semantic routing, and we'll talk about that a little bit later, about basically making decisions as to which model to use based off of which use case. Because if you're driving on Le Mans 24 hours, it makes sense to have a Ferrari. If you're driving to the Wawa, you can do it in a Volkswagen. So you don't need high performance for those use cases. And then when you got infra, it's all about right sizing. It's all about auto scaling, and it's all about leveraging different budget schemes like spot and cuts.
Hey, Len, as a question in here, are there any model? I feel like when you were kind of demoing last week, you were talking about like the different models, grounding. Is there a cost optimization related to which model you're going to be using?
Yeah, so there is actually a tool built into Gemini Enterprise that allows you to make decisions about which model to use. It's actually a part of our eval capability. Essentially, it can make a recommendation to say to you, hey, you could potentially do this with a different model. And it basically does it based off of the eval result. So if it's a capability that's built into evals. And actually, our AI specialists also have a different tool. One of the things that our AI specialists do when they're onboarding new customers is they go through this kind of eval process with them to basically figure out what are baselines for performance. And in those sessions, they'll help guide you as well. They'll basically say, hey, does this really make sense for this type of model? Because at the end of the day, it's not just because we're saying that you should reduce your costs. We don't want you to use a model that you don't need either, because that's taking away from folks who actually do need the bigger models for certain purposes. So yeah, there's a couple of different ways in which you can accomplish that. One is using our eval service, and two is when you talk to one of our AI specialists, they'll help you try to give you decisions onto what makes sense for a model.
The eval service, is that like a special link that someone?
No, it's built into Gemini Enterprise. So it's one of the capabilities of Gemini Enterprise Agent Platform is the eval service. It basically, essentially, if you deploy something, like say you're leveraging Anthropic Claude and using our Anthropic Claude endpoint, you can enable evals. And one of the things that evals will do is actually give you an idea for how things like time to token, also things like it'll basically give you a way to judge how well the model fits the use case that you're using it for. So I'm not an expert in that in any way, shape, or form, but I've seen it demoed before of how it works. And the idea behind it is that it'll help inform you as to which model makes the sense for your use case.
Great. Thank you so much for answering the question.
No worries. No worries. And if anyone's interested in that, I can arrange a meeting with an AI specialist who can really get really deep down in the weeds with you on this, because this eval thing, it's kind of thick sometimes, the details of it, but it can really give you a big benefit, because it's exactly like you're saying, which is, I want to know if I'm using the right model for this. And that's one of the things that the AI specialist can help you do it too. And if you want to do it by yourself, you can leverage the eval service in enterprise. So one of the things is that you want to structure your resources so that you have strict boundaries between operational and finances. And so one of the, if you've used other platforms, you've probably seen that they organize stuff differently. For us, we have account, and in an account you can have multiple projects, and resources are actually tied to projects. But then you have we give you another mechanism in which you can organize stuff called folders and organizations. So when you can establish an organization in Google Cloud, and in that organization you can put a folder, and that folder can do a bunch of different things. You can do things like specify policy that impact that folder. You can also do things like network things, like special network things associated with stuff in that folder. Similarly, you can go down to the project level and do some of those same things. So you can have policy that affects just that project, or you can have networking things that just impact that project. And then any project in that folder will inherit all the things that come from the folder and the organization. And as you can imagine, you can do all sorts of complicated trees that inherit policies going across and down and whatever you want to do. And so that's something is to understand that when you set this up, you want to make sure that you have organization-wide billing policies. You want to map folders to business units or environments. And you want to have strict billing boundaries based off of that. So you don't want to mix dev or prod in the same project, for example. And I know it seems like a lot, but it's not really. You get used to spinning a project for stuff. I mean, the only gotcha to this is leveraging networking so that you can do like VPC to VPC communication across projects. But we also have a notion of what's known as a shared VPC that makes that very easy, actually. So it's something that we recommend for best practice, and it's not hard to set up. So another thing too is that you want to have your IAM set up so there's a separation of duties, and this is critically important because you want engineers to be able to provision resources, but you want FinOps to be able to control how billing happens. That's really super critical, because once project owners can do stuff with billing and everything else, it breaks your FinOps basically, because they'll just go off and do whatever they want to do. So that's one of the things that when you set up your organization in Google Cloud, you actually have to set up things like billing admins, which have the ability to change the billing account for a project, whereas you can set up project owners to not have that permission. And the big recommendation there is to limit billing account creator role. So that's the role that exists, billing account creator. And then we would recommend using project vending, using infrastructure as code to guarantee that billing is linked up the way you want. So that's just something that I would say is table stakes. Now, of course, if you're a small org and you only have one project, are you likely to do this? No, but this is how, I would say you should start down the Terraform journey as early as you can, actually, because this is the type of stuff that you can automate so you don't have to think about it. So if you're a small org, yeah, I'm not expecting you to do this stuff like this, but if you start using Terraform right away, being able to implement this stuff is easier. And if you start implementing it earlier when you're smaller, trust me, when you're scaling and you hit that hockey stick, you're not going to have time to do it. So do it when you have a little bit of luxury of time to do it, and it doesn't take that much of a heavy lift, such that when you do get to the point that you need to vend lots of accounts, it's already set up. So one of the big things we say is that labels are non-negotiable. You absolutely have to implement labels. Labels is how you basically mark something, a resource inside of Google Cloud. And the idea is that you can actually enforce this in an organizational policy that basically says you can't deploy something unless it has a label. And you want to do AI-specific labeling for things like resources, custom training jobs, notebooks, all the stuff that you can use in Gemini Enterprise. And then you want to enforce it with organization policies so that you basically block the creation of machine learning resources, or especially compute resources, without the proper labels. Because you want to be able to make sure that if someone did spin up an expensive GB300, you know who it was so that you can go back and do chargeback. Or you can, if something's left hanging, you know what it was for. Or if someone is using a LLM and they're doing 1 million queries per second or whatever crazy thing, you better be able to go look at the label to see what it's for. Because the thing you got to remember is that the folks who are doing, unless you're a really small org where you are both the billing admin and a project creator, you're not going to be in the mind of the people who's monitoring the billing. So you want to leverage labels such that you can kind of communicate across, so that someone who's monitoring your billing is going to be able to see, oh, this is team X. They're spinning up. This is why they're spinning with GB300. I know why, because that's the person's responsibility for billing, is to monitor for things that are different or to make sure stuff is accounted for. Now, we have a built-in capability in Google Cloud now we have a billing console. So the billing console has a bunch of capabilities, but we highly recommend for folks, especially if they know that they're going to get a lot of spend in AI stuff, to set up the billing export to BigQuery, because we do have a whole bunch of capabilities for doing analysis on AI workloads, leveraging the BigQuery export. And essentially the idea is that you can enable continuous export from cloud billing into BigQuery. And then they allow you to be able to do, there's a bunch of reports that we make available in that BigQuery project that allows you to do things like cost usage. And you can use it as telemetry, actually, because you can get very detailed ideas into this VM that's labeled production mosquito project 1 GB300 was running for 24 hours. That's the type of detail you'll be able to get, especially if you've enforced labels and stuff like that. And then the good thing about that is that once you get this telemetry, you'll be able to start establishing unit economics based off of it. Because if you know that label for, say, for example, you're doing LLM calls and it's labeled that it's being used for the prod mosquito project, you'll be able to go in and use that information to be able to populate a dashboard that can tell you things like token consumption efficiency, like how many of the tokens resulted in a good result for the whatever process that the token is being used for. Because remember, your LLM is going to have the label, but then the microservice that's leveraging the LLM, that's also going to have a label. So you'll be able to look and see, hey, this is how much this session for this application cost, which includes the inference cost plus whatever else it takes to actually process that. And so some of the key KPIs you want to look for is cost per inference, the total, which is the total inference cost by the number of requests. You want to look at consumption efficiency, which is the total cost versus the number of tokens used, and resource utilization efficiency. This is for hardware, where you say actual GPU hours versus provisioned GPU capacity. So that's a way you'd be able to tell whether or not you have overutilized or underutilized capacity. And then the thing is that you want to have that telemetry be able to inform product teams somehow. I don't know if it's going to set up alerting or if you want to provide dashboards to the financial team, so that to the product teams. So one of the responsibilities of you in the billing side is to give visibility to the product teams to this telemetry. So they'll be able to see the impact of their prompts. So they'll be able to see, hey, that project that you have that you just deployed, it's very low consumption efficiency. You need to retune it, because we can't have something having very low consumption efficiency. Or if they spun up a GPU, hey, this thing only has 20% utilization. What's going on? Can you perhaps collapse that workload onto this other GPU that we have that's run by this other team, for example? So this is one of the easy ones to pick up on. The BigQuery export will allow you to see high monthly node costs, especially if it's co-located with minimal API traffic. So the idea behind it is, if you have an expensive A100 running for like 24/7 and then there's zero traffic, you want to be able to tell that that's happening. And once you establish that, then it makes sense to perhaps pivot to a different way of doing things. For example, one of those mechanisms is to move from scale to zero to batch. So instead of having something where you just have it running 24/7 because for whatever reason, you can instead have it use batch operations so that it only exists for when it needs to run. And there's a bunch of different ways you can do this. One, you can schedule it yourself. You can also leverage, we have Cloud Scheduler, which can be used to schedule things like this, or batch. Batch can also be used to do this because you can specify in batch that it's a GPU that runs your workload. And therefore, and then also for APIs, we do have batch processing available as well. So if you don't need near real time for an API endpoint, you can leverage the batch features of Gemini, for example, to get a similar capability to this, which is basically only use stuff when you need it and not just have stuff hanging around. Yes, Rudy.
Is there a similar process for like K8 stuff or for Kubernetes where you can do some type of predictive and batching as well?
Absolutely, 100%. So, I mean, it depends on when you say it. So in Kubernetes, you have jobs. So you can establish jobs for doing stuff rather than a service. So a service in Kubernetes would have something spin up and a node would always be sitting there running that container. But if you specify a Kubernetes job, the container only exists to run that job.
Got it. Well, the reason why I brought that up is just for like load, right? So we kind of have, we use K8s and we know when stuff is high and we know when things are low. So I was curious to see more predictive where things can kind of like extra nodes could spin up, predictive or preemptively, essentially.
Oh yeah. So GK does that naturally. It's called predictive autoscaling. So that's something you can turn on that basically allows GKE to make its own decision as to spin up nodes to be able to service your workload. Okay. So that's actually, it's under predictive autoscaling. It's something you can enable. Then the other thing too is that autopilot also does some of that as well. Essentially for the first 2 weeks after you spin up a cluster, it kind of learns the behavioral pattern of the cluster. And if you're using autopilot, it will actually inform scaling decisions. And then if
we're not, so that's probably why.
Yeah. So you can enable predictive autoscaling to help you make decisions about stuff like that. Okay, so this is when I was talking. Oh, there's another question. Hey, Dominic.
Yeah, sorry. Thank you. Kind of on the last slide, you were talking about the tagging for like cost telemetry. Is there a way that you can also add like quotas at a tag level?
Yes, I'll talk about that a little. And it's labels. Tags is a networking construct for us. I know Amazon calls tags.
Oh, right, labels.
Yeah, it's labels. Yeah, tags is a network construct for us. So you'd use a tag to basically specify that this VM can only talk on this firewall rule. So that's just yeah. It's just.
And then I guess just maybe a piggyback off of that. And you can tell me if we're going to get to it. But can you also add like dynamic labels? Like I'm thinking about like for us to kind of get granularity at a customer level when we're productizing some of the inference.
When you say dynamic labels, I mean, you can attach labels however you want, and you can put the logic to insert whichever labels you want. So if you have an API endpoint, you have the API endpoint attach a label to a request, but that would be on the request. It wouldn't be on the resource.
All right, cool.
Yeah. So you can attach labels. You can do that yourself. Right. Track it that way.
Nice.
Okay, so this is what I was talking about, where you basically pick models. And one of the ways in which, this is actually one of the recommended ways actually, is rather than have user requests that go directly to a model, you kind of do like the open router thing where you have an API gateway and then it has some sort of intent classifier, which basically makes a decision about what the intent you're trying to execute for the request. And then it basically redirects it based off of some sort of logic for determining which model it should go through. And the idea behind it is that gets you to do tiering for the model usage based off of what the results you want. So if you have a high volume thing that has low complexity, you might as well do Flash with. And by the way, Flash scores really highly on the intelligence scoring, by the way. So don't think of Flash as something that is like a dumber model. That's not what it is at all. It's really about speed. And so if you got something that's low complexity, don't be afraid of using a Flash model. And then similarly, if you have something that's high complexity, don't be afraid of using a more complex model. And the idea, the best analogy to look at this is that you wouldn't use a 96 mode machine to run a cron job. You wouldn't use a flagship model for regex replacement. You want to use some sort of gateway to dynamically assign models based on intent. And that way you can reduce costs and also have faster time to first token if you're using something that requires low latency. The other thing you want to look at too is once you start using this at scale. I know everyone they're first starting, they're just like they're glad to have any prompt to submit to LLM. But as you start using this at scale, you want to look at your payloads and make sure they're not bloated. And the two main mechanisms for doing that is to leverage vector search to basically optimize what you're submitting to the LLM, and then also prompt caching, which is a capability that basically allows you to offload some of the tokens in a prompt and have it come from a cache. So instead of you can use to vector search to basically inject semantic context into the context window rather than you just blurting out this whole thing and to enter as a prompt. You can first do a vector search and then have the RAG submit just semantic context to the prompt. And then prompt caching allows you to reprocess system instructions on every API call without having to pay the cost for a token input. And these are all capabilities that are built into pretty much most of the models have. I mean, all the models have vector search, and I think all of them have prompt caching capability. The other thing too is about AI environments. It's super critical to not, I mean, back in the day, we used to recommend this for folks too. When you have a dev environment, don't just have it running, especially if it's an expensive resource like a GPU. So what you can do is you can do automated shutdowns or set up something like a PagerDuty alert to tell someone that they left something running. And the obvious thing to do is have stuff come on at 9 a.m. and shut down at 5 p.m. That's an obvious thing to do. You can set that up as a time schedule thing, or you can set it up based off of utilization. Like you can say, hey, when utilization for this box gets to 20%, then it makes sense to shut it down. And you can implement, there's a bunch of different ways to implement that. And then you can also do it based on a budget as well. So you can establish a budget on a resource and then essentially have it say, hey, you have a cloud function that's responding to PUD sub whenever the budget notification goes out. And if it hits that threshold, then have the cloud function shut down the resource. So that's something that you can do. And we have plenty of examples of how to do that in code. The thing about it too is that you want to kind of, basically these are like the main patterns for how you can overall reduce the lift it takes to actually implement certain types of workloads. So hardware tiering is basically looking at different types of GPUs that make sense. Not everything is going to require a GB300. There's plenty of stuff that could run on an H100 or even a G2 or an L4. And that is a huge price performance difference. Like if your model can fit in 24 gigs, use a G2. There's no point in trying to get an L4 or even an A100 or H100 to run that workload. And especially if you don't have a time component to the request that you're making. And then of course, you want to do distributed training. You want to maximize your resource utilization. And there's a bunch of different things you can do. For example, you can have mixed GPUs across your fleet in GKE. So you maybe use tolerances or something like that to determine that, hey, this type of workload requires the expensive GPU model, whereas this type of workload can do the cheaper GPU model. And then leverage CUDs to lock in capacity for baseline predictable pricing. And you can reduce your node hour cost by as much as 70%. I mean, it's just an image here that, because you can get to 30% of the spend that you're doing now with a 3-year CUD. And of course, 60% of the spend with a 1-year CUD. Another thing, recommendation is you can use a kind of elastic inference architecture. We actually implement something similar to this in GKE, but this is something that you can implement for yourself, which is you have an API gateway in front of you. Say you have a microservices that leverages, say, an agent or just LLM, or just that's responding on behind the API gateway. You want to have some sort of strict rate limiting. This is particularly for SaaS systems. So if you have a user microservice that's hitting your API gateway for some sort of inference, you want to put strict rate limiting and quotas on top of that. You don't just want folks to just be able to spin up whatever. Actually, one of the sneaky ways in which folks are taking advantage of folks' endpoint is if you have a system right now that directly takes inference calls from user requests, that is a system that is open to abuse, because people will actually use those systems to do their own work, for just leverage your endpoint to do their own work. So one of the things you want to do is you want to put rate limiting and quotas using API gateway, and it's pretty straightforward how to do that. So I would say if you have any sort of, if you have anything that has an endpoint that leads into inference in your platform, consider putting API gateway in front of it so you can do rate limiting and quotas. So the other thing, and this is, I mean, this is somewhat controversial sometimes when I talk to founders, is that you want to switch to app dev over doing infrastructure. And what I mean by that is if you're just doing infrastructure, you're going to spend a lot of toil because you're eventually you're going to run your VMs. You're going to have to do the patching. You're going to have to do the capacity planning. You're going to have to manage your GPU nodes so that you don't run out of money. And that can just become a very expensive thing. If you're leveraging serverless and managed services, you don't have as much toil. I mean, that's just the way it is. So if you can run your workload in Cloud Run or Cloud Functions, there's a huge impact for you for toil because this is, you no longer have to spend all this time just making sure the system is running. You can actually spend more time working on the solutions that you have. And similar thing for managed databases and AI. If you use the managed services rather than run your own inference, you're just going to spend a lot less time at work. And the funny thing is, a lot of folks, not just founders, a lot of folks in industry make the mistake of not accounting for the actual cost of toil. It's expensive. Just because you have somebody who's able to go reboot a machine or install a patch or something like that, imagine if that person could actually do something that's directly relevant to your business. It's not essential to be able to spin a box up and down, or do a patch. That's not your business. Your business is whatever your business actually is. It's not actually like managing servers and stuff like that. In terms of GKE, we always emphasize bin packing as a way of basically minimizing the amount of nodes that you need to run your workloads. You can use a feature called VPA, Vertical Pod Autoscaler, and it will actually make recommendations for resource sizing. Now, I know everyone's using HPA because it spreads out the nodes, but VPA can actually tell you what the right size for a particular node for your workload should be. So if you deploy VPA, it'll actually give you an idea of what the node size you should use for your workload. And then you can use bin packing to basically maximize the usage of nodes. And then basically do things like scaling down, doing off peak, so you're using less time that is necessary. And then, of course, use the hardware that's critical, that you absolutely need for the workload. You don't need A100 or H100s for everything. If you can get away with L4s or G2s, do it. And if that means you have to quantize your model or something like that, that's perfectly fine as well. Because at the end of the day, you want to spend as little money on this as possible. So when it comes to cloud storage, this is basically like I guess a worksheet to think about it. Now this works for all the different storage types actually, but this is particularly the capabilities inside of cloud storage. But when you look at like block storage options, we similarly have different tiers that you can use depending on your use case. But for cloud storage, you got the standard tier, which is what you would use for high performance. The access for that has to be high frequency, and it's at the highest rest cost, and has no retrieval fee. Nearline is really for backups, short-term ML logs, and the idea is that you would only use that once per month, meaning you would retrieve something from it once per month. It has a lower at rest cost, and has a low retrieval fee, and it's a 30-day minimum. It has to stay in that class. And then cold line is more for disaster recovery. If you only access it once per quarter, then it definitely makes sense to use cold line. And it has a very low at rest cost and a high retrieval cost. And it does have a 90-day min. And if you look into the cloud storage, basically what it says is that if you retrieve it within 90 days, you get less than 90 days, you get charged the full cost for it over time. But if you retrieve it after 90 days, it's a lower retrieval cost. And then archive is worm. It's something that's only designed for use once per year, and the minimum retrieval is 365 days. And you can implement what's called as object lifecycle management to actually have stuff automatically move between classes, especially for your ML workloads where your workloads are changing over time. There's definitely it makes sense to move some things that you're not using into different classes. Now, one of the really important things to know is that you can set budgets at the billing account level and the project level and at the service level. but it probably makes sense to really put it at the resource level. And the reason why is because then you can get very detailed information on actually what's happening. So that means if you have a container that's running for this particular workload, then you want that container to have the label. You don't necessarily want to say all the stuff in Cloud Run has a particular label, or all the stuff in this project has a particular label. So you want to get detailed with it and say that this team 6 running the financial workload is what this container is. So you want to make sure labels are on the lowest level, and then you want to set budgets on that lowest level. So because you can set budgets on the label, you can set budgets on the service, you can set budgets on the project and a billing account. So it's just something to scope your budgets to the label. And then you want to also, something we also recommend is do forecast triggers. Now, folks are used to actual triggers. So when something hits 50% of your budget, you would alert. But what we're suggesting is also leverage forecast triggers, because that'll really save you in that situation of like something is out of control. So if you put an actual spend, like say for example, your key got leaked. Now you could set, if you set the budget as alert as 50% of budget, that's cool. But that 50% may happen after 1 minute. But if you set your forecast trigger at 80%, and your forecast trigger will trigger very quickly when it sees it start going up like that. And that'll alert you to potentially even before it hits 60%. So that'll give you more time to respond to something with a forecast trigger than with an actual. Because another thing too is that it'll also catch the situation. Based off of experience, a lot of the nefarious people do probing. And what I mean by that is when they first get access to something, they will spend 1,000 and see if anything happens. Then they'll spend 100,000. And what the forecasting will do, the forecast will trigger you to that quicker than the actual. Because the reason why they spend 1,000 is because they don't want to trigger your actual trigger. They want to be able to use as much as they can before you cut it off. So that's why we recommend using forecast triggers rather than actual, because that way you'll be able to catch those folks who are trying to be sneaky. Another thing that you want to do is once you set up your billing alerts, and that includes actual triggers and forecast triggers, and of course on the lowest granularity you can on the container if possible. You want to then have billing alerts go into PubSub. And the reason why is because you can then establish cloud functions that can monitor the alerts and then take action. You can have soft guardrails. So what that means is that maybe Slack PagerDuty that tells, hey, maybe take a look at this because maybe something's about to go wrong. You also want to be able to implement some API quota limits as well, because this is something you can do as well. You can set up quota limits for APIs inside of Google Cloud. So you can do it across all our APIs. You can establish quotas, but you can also use the cloud function to establish it as well. So you don't have to use the capability we have in the platform. You can also use the cloud function. So basically you could do something dynamic. So basically say you have a logic that says, hey, if this program is making a Gemini call, I only want it to do 1,000 of those calls a day. Then you could throttle that service based off of that. And then you could also implement a kill switch. So one of the things you can do in Google Cloud is you can actually remove the billing project, the billing account from a project. And what that'll do is that it'll terminate all resources in that project that cost. So this is kind of a kill switch. It means it will delete things. So if there's anything in that project that costs, it will delete it. But it is an absolute kill switch. You can do that in Google Cloud. Basically remove the billing account from a project. So basically there's 3 different levels of stuff you can do. You can either just notify someone and say, hey, take a look at this. You can limit something yourself and just tell it to no longer process any requests, or you can literally shut down the project so that there's no billing from it whatsoever. Now, here's some of this is some of the coolest stuff I think in the platform actually. So Active Assist is something that a lot of folks don't notice it when they go inside the console, but it essentially uses AI to make decisions about what you're doing in terms of your spend. And it'll come back and give you information based off of your historical spend to basically make recommendations. So it'll look at things like, hey, you use this, if you ran an E2 with 5 vCPUs and that machine was only 20% utilized for the last 30 days, it'll come back and tell you, hey, you perhaps can use a smaller instance for this. So maybe scale it down because you're only using 20% of CPU. So the big thing about Active Assist is it's data-driven telemetry. It's not making guesses. It's looking at your actual use of resources in your project and making decisions about what you should pay attention to. And what it tells you is actionable. It's not just telling you, hey, this CPU is not being used. It'll actually come back and say, hey, scale this back to an E2 4. That's literally actionable stuff it gives you. And then the other thing too is it gets you out to make a cultural shift. You're using deterministic performance data. You're no longer using fear as the driver for stuff. Because everyone logs into their account and worries, oh my God, I hope something isn't running like this anymore. With Active Assist, you can kind of be more deterministic about how you respond to things like that. And one of the really good use cases for this is exterminating idle resources. It'll look for VMs that are not being used without giving any value, and then allow you to basically reclaim that budget for zero impact to prod. So that's actually one of the best use case for this, actually, is that to go out and notice that stuff isn't being used and say to you, and it'll actually say to you, hey, this machine is not being used. Perhaps you should consider deleting it or stopping it. We also have a feature called FinOps Hub, which is built into our console. And this is what it'll look like. It'll actually give you a ranking for how you're operating your project to be able to tell you, hey, your org is this efficient compared to other orgs. And it'll also provide you actionable insights as well. It'll tell you, hey, perhaps you need to go purchase some CUDs, or hey, you need to right size this VM from 14 vCPUs to just 10 or something. And it's a single pane of glass. If there's anything you take away from today, go check out FinOps HUD or enable it in your account if it's not enabled. Go enable it and then take a look at it, because that stuff is golden. It can be, in fact, honestly, if there's one thing you take away, go launch FinOps Hub, take a look at it, and see all the stuff that it tells you about what you can do to save money. And the other thing too we have is, and this is something you have to turn on, we have Gemini Cloud Assist, which is not just for resources. So in Gemini Cloud Assist, you can go in there and say, hey, how many Cloud SQL databases do I have? Literally natural language question. It'll tell you. But what can also tell you is billing analysis. So this shows a query that you would use for querying a BigQuery export for your billing information to figure out your top 5 services. You can actually go into Cloud Assist if you enable it and ask this question. Show me the top 5 services that cost me the most money last month. And it'll produce you just like this. It's frictionless and it's natural cause, and it does root cause analysis. So yeah, I mean, that's the idea behind it is that we want to make it easy as possible for you to be able to gain insight into your financial spend. Another thing that's enabled as well is you can do cost anomaly detection. This is a feature in our billing console. And essentially, once you turn this on, it looks at spend patterns and establishes baselines for cost trajectory. And then it'll alert you when something is significantly deviating. So when you come into and you can set up alerts based off of the cost anomaly detection. And you can say, hey, this is unusual. And so it looks at your pattern of spends. And then if something is unusual, it can alert you based off of that. And that's something you can enable in the console. Another thing that you can also use, and it comes out of the Cloud Assist family, is you can do anomaly root cause analysis. It can basically allow you to, this is actually a part of there's a whole bunch of features we have around doing investigations and using Cloud Assist. This is actually one part of it, which is anomaly cost analysis, which you can, once you enable this, you can basically look and see which thing led to an increase in cost that was just unusual for you. And one of the things, so this is actually kind of like a chart, and I'll share these slides with you as like a generic way of looking at how you want to approach using VMs in terms of how you can minimize your cost for them. If your workload is fault tolerant, stateless, or batch, if it's absolutely that, then you want to use spot VMs, and you can get incredible savings up to 91%. If it's not stateful or batch or fault tolerant, then you want to use CUDs. So that way you can minimize the cost. So it has to be something that's running for a long time. So then you can use CUDs. And then if it's absolutely not something that has some sort of baseline, then use on demand. And what we mean by that is if it's bursty, it fits on demand. If it's consistent, use CUDs. If it can be run in a short amount of time and that you are not concerned about it being fault tolerant, maybe it's stateless and can switch from machine to machine. Preemptive. Use spot VMs. Now, a lot of folks have the misconception that spot VMs mean you won't be able to run something on them for a long period of time. That's not what it means. It means that you have to be able to prepare for something to be able to shift from one VM to another. That's the only, and then the other thing is they actually did stats on whether or not people get preempted with Spot. It's actually rarely happens because folks just know that if they're using something for Spot, they use it for a couple hours and then they're fine if it switches to a different VM. So folks hardly ever get actually terminated. You have to plan for it, but it's rarely ever going to happen. So the guidance we have for CUDs is basically you want to do the baseline, the waterline. You want to do the usage that is consistent. And as you see there, the blue area is where you would purchase a CUD. So you want to look at your usage of resources, and the blue area is how much CUDs you want to do. Now, typically that blue area is going to be 80% of your usage. That's typically where you would see the CUD line goes. And then you can use on demand for any of the bursts because you don't want to oversubscribe CUDs. You want to use it for just what it needs to. And you want to filter out atypical usage. So if you just spun up a machine and you did stress testing, don't use that to establish the baseline for CUDs. So this is the walk on crawl, right? And crawl is mandate strict resource tagging, enable BigQuery billing exports, and if you can see, you can optimize it. That's basically the rule of crawl. So at the very least, you want to have resource tagging, billing exports. The real best practices in automation is to implement active assist right sizing. So when active assist makes a recommendation, right size it. Enforce GKE node bin packing. There's a bunch of different things you can do. Even in code quality analysis, you can ensure that bin packing is happening. And then you want to set up programmatic budget alerts via PubSub. And what I mean by that is you set up budget alerts that go to PubSub, and then you have a cloud function that responds to that to either send a notification or potentially terminates resources. Hey, Rudy.
Had a question about on the last slide about the CUDs and so forth. I know that there you can do like is it spin base and then resource base? Because we
spin base and resource based CUDs. Yep.
What and how? Like how is it? How can you leverage that if you think there's an opportunity that your resources may change moving forward?
So there's a bunch of different CUD types we have. We have what's known as flex CUDs. And flex CUDs that basically says, hey, I can use this compute across a bunch of different services and of course of different types. Now it has less of a savings than resource-based CUDs, but it gives you an opportunity to save some money that can be. So for example, if you know that you're going to be using the N2 family and you want to be able to make sure that you can use the latest N2 instances, you can just purchase a flex CUD for N2. So that means you can use the current N2s. And then if down the road we introduce a new type, you'll still be able to use that. And then you'll be able to use it across services as well. So flex CUDs would say you can use it across service, whatever. And resource CUDs, you can use across services as well, but it's bound to a specific type in a region. So a resource CUD would be N2-4 in USDs. Now that would mean that you could potentially use it in Vertex, but it would have to be in that specific region, right?
Mm-hmm. Mm-hmm. Okay. Thank you.
So the run is when you're using cost per transaction for an AI token. You're using Gemini FinOps for RCA, and you're tying cloud spend directly to business value realization. That's when you know that those are the things that you want as outcomes for doing you're running now, right? But like I said, start with resource tagging and build BigQuery exports. And then perhaps the next thing absolutely to implement is to do programmatic budget alerts. I would say that's bare minimum, I would say. So if there's any key takeaways, the big ones would be focus on app dev. I mean, I know everyone wants to implement their own infrastructure and everything like that, but the toil for that is actually a cost vector that folks don't think about. And if you have a developer who's spending a whole day spinning up a box, that's a developer who's not building something that you absolutely need them to do. You want to drive financial accountability. And what I mean by that is you want folks in your organization to be able to get visibility in how their work drives spend. So you want to push cost visibility down to the engineering teams who are provisioning resources. You want to embrace automation because honestly, trying to do all this stuff manually is going to be too much time for any individual. So you want to use active assist. You want to use programmatic guardrails to define your budget. There's a bunch of different things that you want to do. There's a bunch of different things that you'd want to do to basically control cost. And then there's a couple of reference architectures that we have for pricing. Here's some links to it, and I'll share the slides with this as well, so you'll be able to get to those links. And yeah, that's the overall the answers to all the questions I have. Are there any questions about any of that?
Len, you mentioned earlier that you kind of had an offer for teams that are interested to maybe link up with like an AI specialist.
Yes, absolutely.
Kind of like drill into, I think the eval suite you'll offer.
Absolutely.
How did I take you up on that?
Oh, just send me an email. Plus, we got Gunnar on too. You can email Gunnar as well, and we can
Gunnar, cool.
Set that up.
Thank you.
Any other questions about all of this stuff?
I'm gonna leave this meeting and look up what Kubernetes autoscaling means. So, this was great. Does anyone have any additional questions? Okay. I know we're one session away. And so for folks who are going to be involved in the capstone, I'm going to be organizing a call for probably Thursday. I might end up using what was the founder lunchtime, and feel free to join it remotely. That's fine. And I'm trying to think. So I'll be organizing that. I'll also probably at the end of Thursday be sending out something like I hate surveys. It'll probably just be like an open box of give me some feedback. We're hoping to keep our relationship going with Len, and maybe he'll come back in a couple of months, because I just feel like with AI, everything is changing so quickly. So we probably need to, if you're open to it, Len, we'd love to at least make this like an annual thing with you to go over what's new. I know that, we've got 180 portfolio companies. So we picked topics that we felt would be relevant to at least, each portfolio would find use in at least one of the sessions. But I also know like some of you might want to go deeper on some things. Some of you, if you're like me, would be like, hey, can we start at the very beginning? So any of that kind of information too, just to make sure that we're delivering presentations that are of greatest value to everyone, would be really great. But yeah, that is it for today. And then keep a lookout for an email from me regarding planning for next week's event. Okay. Anything else anyone wants to add? Okay, good. Cool. All right. Good to see all of you. Thank you, Len.
Thanks, y'all.
Thank you.
Recording for this available as well. All right. Take care, everyone. Bye.
Bye.